Now we'll move on with the expert talk, the series of expert talk by the advisory board members of FOSSEE, OpenFOAM team FOSSEE, IT Bombay. And the first talk will be by Dr. Manabendra De.
Very welcome to all of you. It was really a nice, opportunity for me to, again get in touch with the academic circle of FOSSEE, IIT Bombay, and my very near friend, Dr. Bose. So we were discussing this a couple of weeks back, and then it was a dilemma for me because the audience is from a spectrum of disciplines. So deciding the title was very tough. So then we're just giving a thought process to that, and suddenly it struck me that we have recently concluded the 29th UN Climate Change Conference of the parties, which we commonly known as COP 29, and we were talking about emphasizing on the climate finance, building adaptive capabilities, and integrating the nature-based solutions and the clean energy transition with special emphasis on the climate vulnerable region. So keeping in mind all those things and a discussion with my colleagues at NAL, it was apt for this particular day to probably choose a title wherein we can showcase some of our activities wherein we have skillfully tried to use OpenFOAM, keeping in mind the sustainable development goals of the UN, which have been declared a few years back. So in line with that, the flow of discussion will be like this. Just for the formality, I will give a brief overview about CSIR and NAL, and then we will have a bird's eye view of how OpenFOAM was utilized or was attempted to be used in NAL for Sustainable Development Goal number 7, number 11, and also multiple sustainable development goals which are touched upon by the aerial vehicle development program. And finally, I will conclude my discussion with the thoughts that I have. They are only my views, and just a disclaimer that it is not overall view of NAL. So I take the responsibility of those statements that I will be making towards the end of the presentation. So CSIR is a chain of research organizations. We have about 37 labs across India. And the nearest ones to IIT Bombay are NCL, National Chemical Laboratory, and URDIP, who are dealing with the patent and patent analytics. They are located in Bangalore. We have two labs, 4PI and National Aerospace Lab, where I work. And precisely, if you get into the interests of NAL, we have various focuses and various research disciplines. So it's basically like a bouquet at NAL of different technologies and competences and the verticals, research verticals that we work on. One of them being computational fluid dynamics. And our core focus is on civil aircraft and micro air vehicle developments. Of course, we also support the space programs of the government of India as well as the defense programs of DRDO labs. At the same time, the technologies that we develop from all these programs, whether it be civil aircraft programs or the strategic sector focused programs, the findings or the knowledge base that gets generated, we also see to it that we translate it in some way for the societal needs. So that's where areas like wind energy and meteorological modelings have also been researched at our institute. So moving to that, in that direction, the first application where we explored using OpenFOAM was for the Sustainable Development Goal number 7, which talks about affordable and clean energy. And since its inception in 1959, CSIR-NAL has been working on developing technologies for wind turbines and different enabling technologies for harvesting wind energy and also wind solar hybrid systems. So when I joined NLA in 2006, I started working on that. And we were looking at different architectures of wind turbines, which would either be installed in an open field or in the wind farms or in urban areas. So when we talk about designing or conceptualizing wind turbines for urban areas, the first thing what we need to understand is how is the flow pattern over a typical urban landscape. And then understanding of that helps us to choose the configuration. So towards that direction, we did a work. And another thing which I would like to mention over here is all these things that I'm going to highlight today have been done in collaboration with academia, like the students at undergraduate level or postgraduate level, when they came to NL for their internship or their final year project works. Along with them, we explored this unified world of OpenFOAM and tried to see for these kind of applications how do we utilize the merits and all the capabilities of OpenFOAM. So as I was telling, we first tried to understand the wind patterns in the vicinity of the building. So you can see the a very idealistic CAD model of a landscape and its computational domain and the grid details which are generated by snappy hex mesh capability of OpenFOAM. And then we simulated the flow past this building to understand what sort of flow patterns would get generated and what sort of boundary layers get generated over the the vicinity around the building and over the top of the terrace. So, and then try to understand that what is the variation of the free stream velocity vertically above, for example, the terrace of the building, where it is the ideal place for putting a wind turbine. Now, if you look at these results, there can be two thoughts. One is that we try to have a pole which protrudes out of the boundary layer over the terrace of the building, and then we put a conventional wind turbine. But in that case, there will be a lot of structural implication on the terrace flooring as well as the building structure altogether. So this study posted another problem, or we would say another query to us, that whether we can have an innovative shape which can work within this boundary layer where there's a lot of recirculation happening, lot of turbulence is there in this layer, but at the same time we avoid some huge support structure like a tall pole over the terrace of the building. So that query drove us to looking into the nature, which brings us to the next case study, where we tried to see whether we can take inspiration from nature and then borrow some magnificent shapes which the nature has evolved over not just decades but centuries or even maybe ages. As we know, the Darwin's theory of evolution says about survival of the fittest. It is not just that the animals or the birds or insects have revolutionized their characteristics to survive, but also a passive looking thing like a seed pod of a tree also has evolved throughout this period. And they have only those shapes that have survived have are the ones which we see today. So in that context, we thought of looking to the seed pods of two different species, Bahunia variegata and Mimosa, and see that which shape will give us an aerodynamic standstill aerodynamic torque which will be greater than the cogging torque of a typical generator of a small wind turbine. Now, just for the background, if we look at the small wind turbines, they use permanent magnet generators which are notoriously known for the high starting or cogging torque, which prevents them to start in a quick or low wind speeds. So the question here was, can we borrow a shape from the nature which will help to start in a very low wind speed, as low as maybe 1 or 2 meters per second, which is beyond the capability of the conventional rotors, the horizontal axis wind turbines, or the ones which are using the lift type mechanism for generating the torque. So in that context, what we did was we collected these specimens, the specimens of the seed pod, and then we generated the digital twins of that, a series of digital twin by varying two geometric parameters. Over here, what you see is the diameter to the height ratio of these seed pods. And then it, the conventional approach of, meshing the surfaces and then creating the grid for the flow simulation. And it was all done in OpenFOAM. Of course, at that period of time, we were using the body fitted grid. So, we had to approximate the shapes But when I was, doing my PhD work at IIT Madras, I was exploring the possibility of using the immerse boundary method, which is one of the methods used to handle very complicated geometries, and also the ones where you have the, the dynamic meshing kind of a thing, or maybe the moving boundaries, I would be more specific. And luckily, while I was trying to explore that, the OpenFOAM extent had initiated the work, and I believe today it will be at a very, advanced level. So probably one question that I would like to put to the FOSSEE OpenFOAM forum is, to explore the possibilities of seeing the implementation of the immerse boundary method, and exploiting it for, analyzing a rotating uh, blade, the one which we are trying to see over here. So at that point of time, of course, we were handcuffed with only the basic static mesh. So we tried to understand how is the static force or the static torque varying for different, geometric parameters. So that is where you can see over here that we studied the natural shapes for both the seed pods, and then based on the findings of the starting torque, we then moved on with one of them, the mimosa based rotor, and then again varied the pitch to height, or, the number of turns. We varied the number of turns of the rotor, and then again repeated the same understanding to see how the starting torque of the rotor will be generator vis-a-vis a cogging torque of the typical 1 kilowatt permanent magnet generator. So at present, what we are doing is, based on these studies, we are trying to print a 3D model with the help of 4 PhD students who under their societal module under the ACSIR framework, and see whether, whatever understandings we had got from OpenFOAM, whether they are really uh, going to have the same effect, or we are going to have any surprises. But at the same time, as I already mentioned, probably we can use the immerse boundary method sort of formulations in OpenFOAM to see when the seed pod rotates, what sort of forces are generated, and what sort of, characteristics would these rotors exhibit. So this is one example of OpenFOAM. The second one, which I am going to highlight, is from the working group of Dr. T.N. Venkatesh and team, who are from computational and theoretical fluid dynamics division. So, as we know, urbanization is happening everywhere across the globe, and India is also not, it has not remained untouched from there. So, when we talk about urbanization, one of the critical thing that needs to be understood is the urban heat island. Because of the concrete jungle that grows during the urbanization cycle, the problem of the urban heat islanding also grows very much. So this group at NAL, they try to understand how, these landscapes, or the anthropogenic landscapes, how they will affect the wind pattern, and what sort of heat islandings and the effects will get generated in the vicinity of the cluster of building. So they went in a very systematic way, wherein they first simulated the flow past a very idealized domain of two high-rise buildings, and tried to understand the flow patterns that are occurring, and then they varied the distances between the buildings, and tried to see what was the changes that were happening in various features of the building, with the velocity contours or the streamlines of the flow in the vicinity of the building. Having gained confidence on this using the OpenFOAM, the group moved forward towards doing simulation on a real world kind of a scenario. What you see over here is they have attempted to do it, the same study for the Petronas Tower, which is in Kuala Lumpur, Malaysia. It is about 88-storied building, around 452 meters, approximately 1483 feet building. So the same studies which was done for an idealized conditions were now done for across a building which is, in real world it is existing. So again, similar studies were done over here, but apart from the wind patterns, they also, this time they also focused on the thermal effects of the wind, thermal effects of the urban clustering, urban building clustering, and tried to gain more insight into how the wind patterns were going, were getting, changed because of the thermal effects. They did by studying the eddy diffusivity of heat coefficient kh values and seeing, I mean, the basic understanding over here is like, if you have a higher kh value, there is a lot of thermal exchange happening. So this can help us to detect which zones within the cluster of buildings are having a lot of thermal gradients, and then what can be done to address the discomfort that are caused due to that. So having gained experience on a hypothetical but a real world case, this team went forward of taking case of the World Trade Center, which is there in Bangalore, an urban location in Bangalore, and they also tried to understand what is happening in terms of the urban heat islanding using OpenFOAM. So again, you see over here the computational domain and the grid across the landscape that was chosen. And two glimpses of the numerical simulation where you can see the stream tubes and the contour plots of the velocity magnitudes over here. The entire simulation as well as the gridding was done using the capabilities of OpenFOAM. That is the best part of it. This work was done in conjunction with the student from Madras Institute of Technology, Anna University, and Dr. T.N. Venkatesh's team. And probably we will see if the student who worked on this problem can be also, included in the FOSSEE's forum in the near future. So again, here you see over here the plots of KH, and it helps the simulation through OpenFOAM actually is able to help the team to understand the heat transfer in the vicinity of a very complicated flow domain, wherein you have lot of landscapes with different time the sizes. And another part, another innovative part of this simulation was the WRF model, the weather research and forecasting model output was used as the input for the CFD simulation over here. So there was a coupling done between the mesoscale modeling and the microscale modeling in this particular study. So that was another thing which tells us the versatility of OpenFOAM to absorb an input from a computational model which could be of a different scale altogether. Now, this brings us to the third application of where NAL has skillfully tried to utilize OpenFOAM, and that is also from the CTFD teams, the Computational Theoretical Fluid Dynamics team, Dr. B.N. Rajni. And this work was done in conjunction, I mean, the works that we will show over here related to the aerospace domain was done with the SDM Institute in Dharwad. Just a glimpse of that. Some of these informations are classified, so I won't be able to show them, but just they permitted me to highlight these things, like wherein OpenFOAM was used for the NAS project. It was used for the internal flow for the fundamental basic research programs that are given by CSIR. Two of them were highlighted. One is the study of flow pattern inside an S diffuser duct with different bend angle. Now, basically, this is a problem for the aircraft intake duct, especially for the fighter aircrafts, like, say, for example, AMCA or even F-22 and all, where the engine has a duct which, which channelizes the inflow to the engine inlet. So we need to understand the flow pattern, what are happening, the geometry of the diffuser, its shape, its inlet architecture. How does that affect the quality of flow which is going to go inside the engine? So in that case, for this particular purpose, our team had used OpenFOAM as one of the flow solvers and tried to understand the effect of bend angle. The second application where OpenFOAM was again used by this team was to understand the aerodynamics across the RAM air duct of the environmental control system of the SARAS aircraft. SARAS is our flagship program, NL's flagship program, a 19-seater civil aircraft. So the team had tried to use OpenFOAM and understand the implication of the geometry of the air duct on the performance of the environmental control system of the Saras aircraft. Now, these were the examples of internal flow simulation using OpenFOAM. NAL also has a collaboration with our sister lab, National Geophysical Research Institute, NGRI Hyderabad, wherein they do the heliborne geophysical mapping of various magnetic parameters, those things. So they have done work at Ladakh as well as Northeast. Now, before we do that, what happens is this: the study is done like there will be a UAV, and underslung will be hanging from the UAV, and it will be doing this survey. So when we do that, it is very important that when the airflow passes from the underslung, what is its effect on the stability of the aircraft? So here also OpenFOAM was used to understand that when the airflow passes across this hanging underslung, what is the sort of force patterns that get generated over the flying UAV, and how whether there is any chances of getting an destabilization because of that. Also, we have skillfully used airfoil, understanding the characteristics of the airfoil for our SARAS as well as the regional transport aircraft programs using OpenFOAM. And in line with that, the academic projects that were taken were using OpenFOAM for simulating a very elementary flow physics like simulation past circular cylinder or simulation of the airfoils used in MAV applications. So these are some of the glimpses where OpenFOAM, along with another flow solver SU2, which is from Stanford University, were used. And apart from that, the in-house code 3D Perl, there is a hybrid RANS LES code. They were also used to understand the variation in the aerodynamic coefficient across different airfoils for the different angle of attacks for different turbulence models. And you can see over here, we have very good, similar trends between the in-house codes as well as OpenFOAM, and their comparison vis-a-vis the experimental observations that are available. Of course, here, moving from 2D simulation, OpenFOAM was also used for studying the flow past rectangular thin wings, which are very typical for the UAMs or UAVs, and the overall appreciation of how the in-house code OpenFOAM and the measurements, how they do vis-a-vis each other. These are some of the glimpses. And moving further with a practical example of flow past the fuselage. So this was another study that was done using OpenFOAM as well as the in-house flow solver. And unlike the previous two groups, that is my group as well as Dr. TNV's group, here the grid generation was through either ISM CFD or using point-wise grid gen, which are commercial grid generators. So again, here the versatility of OpenFOAM was established, like, it is able to not just absorb the input from a third party tool, but is also able to absorb the grid which is generated from third party. Like, if we don't use the snappy hex mesh capability of OpenFOAM, we can make the grid in a third party grid mesh generator and then use it in OpenFOAM. So this over here is just a glimpse of how the pressure contours were predicted by OpenFOAM and 3D Perl. And you can see that a very good match between both the solvers. One is an in-house solver and one is the open source solver. So with this, I would just like to share my concluding thoughts. We have a dire need to use OpenFOAM framework for both academic and industrial research, and the platform for exchanging notes and discuss the issues that are being faced by the OpenFOAM community is imperative. Of course, a pool of HR which has an expertise in handling OpenFOAM will be really a boon to the Indian and Indian industry as well as the research fraternity. And as we see the NABLA sign, which is a part and parcel or the integrated part of OpenFOAM itself, gives an indication that the need of an hour is to realize a research triangle wherein the academia, industry, and research organization come together and we try to see how the magnificence of OpenFOAM can be extended to the various challenges which the academia as well as the industry is facing. So with this, I conclude my brief discussion, and I thank the organizers, FOSSEE, IIT Bombay, University of Birmingham, Professor Kannan, Professor Bose, Ms. Payal, Professor Janani, for giving me an opportunity and giving NAL an opportunity to be, a small drop in this ocean. And we look forward to a long-term association with this August forum, and try to contribute with a minuscule level things that we have done at NAL. Thank you very much. Have a nice day. You can reach me on the given credentials. These are my official as well as personal email ID as well as WhatsApp. Thank you very much.